Hello, learners. Hope you are keeping well. Today's lesson is on geomorphology and it's on river grading. Uh, we're going to look at the different aspects according to the exam guideline, and we're going to look at a past paper regarding river grading. So let's get on. Let's first look at the exam guideline and what it actually needs us to study. Let me get my highlighter in here first. All right, my highlighter. Of course, the concept of river grading. Then we have to distinguish between graded and ungraded streams. We have to look at what is base level of erosion in terms of temporary base level of erosion and permanent base level of erosion. Okay, so let's get going. All right, now river grading. I always tell the story in class. The river wants to have the smoothest flow towards the sea. And it keeps on adjusting between deposition and erosion in order to create this lovely, smooth profile that it can head into the ocean eventually. That's its journey from the source to the mouth. So, what is river grading? It actually is a state of balance or equilibrium between the rate of erosion and the rate of deposition. That's what river grading is. There must be an equilibrium. If I'm digging a hole and removing a certain amount of sand, and you are putting the sand back, and each time I do that, you put the same amount of sand back, will the hole form? No. Okay, it'll remain the same. All right, so in the same way, if erosion and deposition is more or less balanced, we're going to have a smooth grading, okay, or river grading. Then let's look at a graded river. A graded river has just enough energy to carry its load. All right, so neither erosion or deposition is occurring. All right. Okay. And this is where you also get a smooth profile. Let me just go a little into it. So if the river has enough energy to carry its load and it's carrying its load, it's not going to knock against the floor or the riverbed or the sides. It's not going to create any erosion. Okay, and if it has enough energy to carry its stuff, it's also not going to deposit. So if the slope was graded like this, it's going to remain graded because nothing is going to knock against it to erode it, or the material is being carried has enough energy, it's not going to be deposited. So that's your graded river. Then we look at profiles, an ungraded profile and a graded profile. All right. What are the differences between the two? Now, let's look at the explanation and a little resource. So we say an ungraded river profile has irregularities, obstructions, or temporary base levels. It is not smooth. Now let's look at this one. There's many obstructions here. There's a waterfall. Let me get my highlighter. All right. There's a waterfall, or pointer rather. There's a waterfall down here. Can you see it? So it takes a bend. It comes down the steep gradient, rejuvenation, etc. Then there's a few rapids. Sometimes there could be lakes in the area. So these are all little obstructions on this river's path to the ocean. Okay, or irregularities or base levels, which I will come to. All right, so this is not smooth. But this is what the river wants to do. It wants to create a new base level down here so it can be smooth. And remember, we said river grading, when it erodes and the erosion is in equilibrium with the deposition, we're going to get this. But at the moment, this is considered an ungraded because of the obstructions. It is not smooth. But let's say the river has reached a graded profile, okay, where equilibrium between erosion and deposition, etc. We're now going to see this. It is a smooth profile. Can you see? No more of those obstructions. It's concave in shape, steep at the top, gentle at the bottom. Okay, so it's a smooth concave shape profile. Steep at the top, gentle at the bottom if they ask you for further characteristics. Okay, so let's look at the explanation of it. It's a smooth concave profile, steep at the source, and gentle at the mouth. It has no obstructions. Okay, can you see the clarity between the two, learners? All right. Then we look at the base levels. One we say temporary base level, and the other one we say ultimate or permanent. So temporary referring to something that's going to go away. Permanent is referring to something that will stay there. Okay, so let's look at temporary first. It's a point along a river's course that prevents it from eroding any deeper at the moment, but may be eroded through in time. Okay, now this results from an ungraded profile. Let's put this into perspective. Okay, it's a point, it can be an obstruction on the river's course that stops it maybe from eroding at that point. But remember, okay, it's going to erode again if there's rejuvenation. All right, so through time it can get eroded. So therefore, it is not permanent. All right, through time and change and whatever, if there's more speed in the river, it's going to get eroded. This is known as a temporary base level. Now, if I look at the permanent base level, it's the lowest point to which the river can erode. Example, sea level. When the river reaches the sea, that's it, the river is over. Okay, it's the lowest point and it's there all the time. So therefore it makes it permanent. Now let's put it into the sketch. Temporary, as the river flows, can you see little points or obstructions like rapids, lake, falls? These are your little obstructions or points that sometimes could prevent eroding, but as through time, it will eventually erode through that. All right? Because rejuvenation will happen here. Isn't it? Rejuvenation will happen here. Okay? And eventually it will be eroded away. That is why your rapid and waterfalls, lake are temporary features. They will go away in times, in geomorphological time, but it takes sometimes millions of years, it will go. So they are temporary base levels. And this is your permanent base level because it's there all the time. Okay, learners? Right. And let me go further. Let's look at the question. River grade and past paper rather. River grading and longitudinal profile. All right. This sketch was taken from a DBE past paper. Okay, so let's look at what the examiners gave us again. All right, river grade and longitudinal profile of a river. Okay, word R is cut off there. I do apologize. I don't think it's the examiner's point. I think I've left it out, the profiles of a river. So we know river grade, that means the river is undergoing grading to remove all the obstructions. Can you see it? It wants to reach that point and it eventually will reach that point. Okay, and then the erosion and deposition must be in equilibrium. Okay, we can see the different surfaces, we can see the nick points that created the obstruction, the waterfalls, the lake. All right, these are all temporary base levels that are there, and eventually, right, through the processes, it becomes graded. We also know that it's a longitudinal profile. It's a side view of the river from the source to the mouth. Okay, we picked up that. Now let's go to the questions. Quite a bit of information we picked up, eh? All right, let's look at the first question. Right. Uh, Give a geographical term. Remember, geographical, you can't just use any other terminology. There could be same words like graded, etc. In other subjects. We have to do the geographical term to describe the irregular shape of the longitudinal profile. Can you see the words again, learners? Irregular. Now, between the two, if I go back here, this is more regular, it's smooth. This is irregular shape. It's got obstructions. Okay, so my answer obviously will be the ungraded profile. Okay, let's look at the next one. Name a temporary base level. You know your temporary. Evident on the longitudinal profile B. Note here, the examiner is not trying to be funny, but he's bringing your focus to it. Profile B. So let's go here and check. What is the examiner meaning? Can't be A, no. It has to be B. All right. So we look at what's found here. The waterfall, the lake, these are the things that are found. So when we go to our answers, all right, it says lake, waterfall. Nick points will be accepted because that's where the waterfall has occurred, and rock outcrops because a rock is jutting out there. So those ones will be accepted. But I would suggest, learners, give them more definite ones that you see. Don't take a chance with this. It's an easy question. These two are labeled there. So use those ones. Okay, let's go to question 3, 163. What evidence suggests that rejuvenation has taken place, all right, in longitudinal profile A? Okay, now, as if you know, when you look at evidence of rejuvenation, we need to see it here. Can you see it? There's nick points, changing in gradient. All right, these things are evidence. Use the definite ones that you see there. That tells you rejuvenation has occurred because there's this erosion occurring in those places, changes in gradient, etc. Okay, so let's go to the answers. All right, drop in original sea level because it seems there that at the end there's a drop in the sketch. Presence of nick points, all right, more than waterfalls. It's an ungraded profile, means it has changes in gradient all the time, okay, because of the obstructions. So therefore, rejuvenation will occur. And of course, we have to give as many options as possible. There's a sudden change in the gradient when you notice those things, when the nick points were there. But if they gave you 2 marks here, learners, I would suggest you go for the nick points first. It's the obvious answer. It's evident there. You are assured of your 2 marks. Go for that first. Not that the examiner's other answers are incorrect. They are correct, but go for the more definite and visible one. Okay. Then let's look at the next one. Describe and notice with reasons changes a river meander will undergo after rejuvenation. Notice what the examiner has done here. He's brought in the concept of rejuvenation. And this is why we need to integrate when we study our sections. We can't study them in isolation. We must try and link them. So we were doing this river grading and all of a sudden rejuvenation appeared. Is it unfair? No. So we're linking up. But also we have to look into this. We say describe with reasons, number one. That's an important thing. Changes specifically to a river meander. So it's a specific question will undergo after rejuvenation. So I see what changes, why, and what changes. Number two, it's focusing on a river meander and it happens after rejuvenation. Okay, so what happens after rejuvenation? The speed of the water increases. So that was going to go through there. You understand? It's going to change it with speed of water, not with less speed of water. Immediately things come to my mind. It's going to cut through the meander, creating an oxbow lake, etc. Okay, so it's about things that are studied. Geography is not difficult. It's about things that are studied and then applying it. That's the important thing. So look at this. Meander will become an incised entrenched meander. Meander will develop steeper sides. Okay, this is like the entrenched meander here. It's a description. It can be accepted. We didn't say just what features will form. We said what changes will happen. Okay, of course, the force of the water will cut off the meander to create an oxbow lake. All right, we showed that, described it. Now, reasons for it, easy. You've learned already. Okay, it's the speed of the river would increase, or energy. The velocity of the water flowing would, when the meander increases. So they've separated it here, energy and speed. And because it's moving faster, downward or vertical erosion will happen. This is more with the incised meander, isn't it? Cutting down, changing that, making the meander deeper. Stronger flow will result in river cutting through the meander neck, all right? And that creates your oxbow lake. Can you see it? So here it will for the incised meander, all right, we would have downward vertical erosion. For the steeper slopes, again, downward vertical erosion due to increase in speed of water. And here, because of the stronger flow, it'll cut through the meander and we'll have an oxbow lake. All right. Now, learners, watch out for these type of questions. Because if I chose an oxbow lake, I would say it will cut off, it will form a cut-off meander oxbow lake. Then I have to talk about this point. Stronger flow will result in the river cutting through the meander neck. I can't just choose anyone. I must make my reason appropriate to my answer. Very, very important. Like when I spoke about entrenched, I would speak about the rate of downward erosion in the meander will increase, you understand, due to speed of water in size meander. So I must link my answers. They must make sense. So the change and the reason. And then 165, this is what happens when you talk a lot. You have to drink a lot of water. All right. So here in a paragraph of 8 lines, explain the processes that assisted Graded River in profile C to have a steep gradient in the upper course and a gradual gradient in the lower course. What processes assisted that? I just want to go quickly back to that diagram. Steep in the upper course, gentle in the lower course. What processes? Now you've done the river profile. You know processes, different types of erosion, etc. that took place there. So let's go to the answer. Can you see how many different sections of this area was tested in one diagram? Can you see? Headward or backward, this is upper course of erosion of nick points will increase the Steepness. When it erodes backwards, it makes it steeper. Downward erosion creates a steeper grade with vertical erosion. Okay? Then what else? It's in the upper course. It's higher up. So the water is mostly turbulent. There's erosion happening. All right. The stream has enough energy to carry larger particles and not deposit them, keeping the slope steep. And also, larger particles do increase downward erosion. Okay? Can you see now why? And you've learned the profile. You know, Edward, downward erosion is happening there. Any two of this, these two are very obvious. You should get them if you studied well. So the question looks quite difficult, but if you unpack it, okay, into upper course, lower course processes, okay, and how it achieves that, okay. So let's look at the other one. In the lower course, lateral erosion will lead to more gradual gradient, all right. You know, in the lower course, it's mostly deposition, but you're getting some form of lateral erosion. Sediments are deposited. You know, the position is the main thing. And if more deposition happens, the slope becomes more gentle. The flow is laminar, more smooth flow, so less rough flow, less erosion. The carrying capacity is reduced due to wider channels. The channel is wide. If it was narrower, the river would flow through a narrow, more energy, more speed. Now it's spread out. So it is actually wider. Okay, so it can't carry as much. It doesn't have that power and speed and energy to carry. Increases friction on the riverbed. All right, and the sides slows the flow, resulting in greater deposition because now the volume is lower because it's wider. All right, so there's more friction, okay, of the material. It doesn't have that much energy of suspending it, etc. So it drags upon the river flow, or the river flow actually slowing it down. Okay, so various things, but again, these are a little more complex, but there's your easy ones here to get your 4 marks. Now, please note in a question like this, you must have both. You can't give 4 from here and nothing from there on the upper course and give everything on the lower course. You will only get 6 marks. You can give 2 and 2, or 3 and 1, or 1 and 3, but you must have both. Okay? Well, I hope this made understanding of river grading a little easier. You keep safe. All the best.